Good morning, dear students. Today we'll have a physics session in which we talk about numericals. As I often repeat, numericals will enhance your learning process. First chapter numerical, we'll have worked example, then we'll move to the exercises. The first one. So it's accumulation of charge concept. Accumulation of charge. What is accumulation of charge? The given information says that 10 raised to 9 electrons are moving from body A to body B per second. If 10 raised to 9 electrons are moved from one body to the other body in 1 second, to accumulate 1 coulomb of charge, how much time is required? This is a given question. Let me go to a share. So I repeat, if 10 raised to 9 electrons move out of a body to another body every second, how much time is required to get a total charge of 1 coulomb? To get a total charge of 1 coulomb on the other body? Yes. Let me do on a board. The question is very, very simple and meaningful. It wants to convince us what is a charge, how charge transfer takes place. If charges are moved from one body to the other body, how much time is needed to compile, to accumulate. Think the body A is here. This is A body. You have another body B. Yes. 10 raised to 9 electrons move from body A to body B. I repeat, 10 raised to 9 electrons move from body A to body B in 1 second. So if that is the case, how much time is needed for 1 coulomb to get it compiled? Let me first calculate. We know that 1 electron is equivalent to 1.6. Electron being a particle, it carries a charge of magnitude 1.6 minus 19 coulomb. I repeat, each electron carries a charge. Charge is a property, 1.6 minus 19 coulomb. If one electron carries this much charge, if 10 raised to 9 electrons move from A to B per second, what charge is transferred? I need to put in terms of a charge. So let me calculate. 1 electron means this much. 10 raised to 9 electrons is equivalent to 10 raised to 9. Electron means electronic charge. So I will be writing it as 1.6 minus 19 coulomb. Simplification of this gives me plus 9 minus 19. The answer is 1.6 minus 10 coulomb. So it means 10 raised to 9 electrons is equivalent to 10 raised to 9 electrons is equivalent to 1.6 minus 10 coulomb. So it means 10 raised to 9 electrons per second is equivalent to, I repeat, 1.6 10 raised to minus 10 coulomb. This is per second. Yes. This much charge is transferred. Now I want to put 1 coulomb here. To put 1 coulomb here, what is the time required? Now, time needed to accumulate, I hope, yes, to accumulate 1 coulomb of charge. You need to calculate charge. So from this calculation, we know that WKT, yes, 1 second corresponds this much charge, 1.6 10 raised to minus 10 coulomb. So if you want to accumulate 1 coulomb, what is the time required? Think it is T seconds required. So I need to calculate what is T. I put it in a simple way. If 1 second it takes, means to transfer charge from one body to the other body, this much charge, 1.6 minus 10 coulomb. My 1.6 minus 10 coulomb moves from body A to B in 1 second. If I want to transfer 1 coulomb from here to here, or I want to put 1 coulomb here, what is the time required? I need to calculate T. Now the formula says T is equivalent to, look at this cross multiplication I can do. T is equivalent to 1 coulomb into 1 second divided by, I have 1.6 10 raised to minus 10. So simplification gives me very close to it is coulomb nullifies, left with a second, it is 1.6, or you make it 0.16, it becomes minus 11. So simple, it is 0.66 10 raised to plus 10 seconds. So if I simplify further, as all of you know, this value is here. Let me put it in a mathematics. So T is equivalent to this T equivalent to, I will be writing this once again. It is 1 by 6 is 0.667. You can write it as, or 6667 you can write. There is no much difference. I can put it 6.70 into 10 raised to 1. 10 I will take, it becomes 10 raised to 9. 10 raised to 9 seconds. Next. So how to convert into years? I want answer in years. So we know that 1 year equal to 3.15 10 raised to plus 7 seconds. So using this concept, I'll be using here. So T equal to 6.709 second means I'll be putting it 6.70 10 raised to 9 years I have written. 1 year equal to this much, 1 second equal to, it comes in the denominator. Now divide it by 3.15. 3.15 10 raised to plus 7. When you do the mathematics of this simplification, we'll end up with the answer 198, close to 198 years. So finally what we got? To accumulate 1 coulomb on the other body, to transfer 1 coulomb of charge from body A to body B, you require a huge time. What is the time? Close to 200 years. So what is the idea? The idea is coulomb is a big unit of charge, whereas 1 year corresponds to this many seconds. Of course, in 1 second, I am just transferring 10 raised to minus 10 coulombs of charge per second. Means body A to body B, you are transferring 10 raised to 9 electrons. 10 raised to 9, it is an electron particle. Electron means it carries some charge. What is the charge it carries? 1.6 minus 19 coulomb. If 10 raised to 9 electrons are transferred from A to B, what is the total charge? The total charge per second is this much. If this much charge is transferred per second, to accumulate 1 coulomb here, I want to put 1 coulomb here. How much time is needed? Time needed by calculation, it is going to be close to T equivalent to 198 seconds. Let me go to the next example. Second example, you can cross check. In 1 second, 10 raised to 9 electrons move out of the body. Yes. Therefore, the charge given to the body is in 1 second is 1.6 minus 10 coulomb, as I discussed. The time required to accumulate a charge of 1 coulomb is then calculated, which comes out to be 198 years. I did on a board. Yes. Next, how much positive and how much negative charge is there in a cup of water? So this will be a very interesting numerical. Let me repeat. How much positive and negative charge is there in a cup of water? Yes, we'll do on a board. So, okay. Let us consider a cup of water is equivalent to 250 grams. I repeat. So the question is how much charge is present in a cup of water, means how much positive charge, what is the magnitude of positive charge, what is the magnitude of negative charge in a cup of water. Water is made up of water molecule, H2O molecules. We know that every element is associated with electrons, negatively charged particles, protons, positively charged particles. Now the question is, let us consider a cup of water is equivalent to 250 grams. If 250 grams of water is going to have water molecules, how many water molecules are present? The first simple question is, we know that 1 mole is equivalent to 6.02 10 raised to 23, yes, molecules, means identical particles in 1 mole. And we know that molecular weight of water molecule, 1 molecule is 18 gram. So looking into all these aspects, let us solve this problem. Means if 18 gram of water is equivalent to 1 mole, then 250 gram equal to how many molecules? Because 1 mole equal to number of identical water molecules. Let me start. Example. Water. Charge. Positive and negative. What's the magnitude of positive and negative charge in a cup of water is the question. Let us consider 1 cup is equivalent to 250 gram. Yes, we know that molecular weight of water is 18 gram. It means that is 18 grams equivalent to 1 mole. 1 mole is equivalent to Avogadro's number of molecules, to 10 raised to 23 molecules of water. I repeat, this is different. Molecular weight of water is 18 grams. What is 18 grams? 18 gram of water is equal to 1 mole. 1 mole equivalent to 6.02 10 raised to plus 23 molecules of water. If this is the case, then 250 grams equivalent to how many molecules? I want this. First, I need to calculate how many molecules are present in a 250. That is 1 cup. 1 cup equal to 250 gram. In 250 gram equal to how many molecules? Once I get molecule, I know each molecule. So I can say each molecule of water, is equivalent to, we know that 2 hydrogen plus 1 oxygen. And the charge of hydrogen, you know that it has 1 electron, 1 proton. I can say 2 electrons, 2 protons. Plus you can say 1 oxygen. 1 oxygen means oxygen atomic number is 8, atomic mass is 16, 8. It has 8 electrons plus it has 8 protons. Together I say 10 electrons, together I say 10 protons. This is called charge, negative charge. This is called positive charge. Means each molecule, 1 molecule of water equal to these many electrons, these many protons. Yes. Now how to calculate this? As I said, 18 gram equal to 1 mole, 1 mole is equal to this much, 18 gram equal to this much means 200 gram equal to how much? Like let me write, 18 corresponds Avogadro's number 6.02 10 raised to 23 molecules. For 250 gram, how many molecules? Call it as X molecules. When you do the cross multiplication simplification, you'll end up with a simplification. X equivalent to 250 into 6.02 10 raised to 23 divided by 18. So when I do the mathematics, you have a simple analysis. 250 into 6.02 divided by 18, because 250 grams of water. Now, this is going to be a molecules. To make it very simple, you can take it 6 1 ja, 3 ja, and 3 1 ja, 3 8 ja, 24, left with, of course, something like 3 8 ja, 20, 240, something like 83 you can take, you can put it decimal place, 83 point something you can say. Then into 10 raised to 23, or I can say which is equivalent to 83 10 raised to 23 molecules. This is analysis for X equivalent to. Now each molecule, as I said, which is going to have these many 10, I need to multiply with this value 10. So I'll be getting the next value. Let me do it here. I will show you. Yes. Next. So X equivalent to 250 into 6.02, 10 raised to plus 23, in the denominator 18. Yes, which gives you, as I said, 6 1 ja, 6 3 ja, something like you'll get 83. So 83 into 10 raised to 23. So this is molecules. So I can say it is 8.3, 10 raised to 24 molecules. Now, if I multiply with it, it gives me some other value. So 3 6 ja 18, 3 8 ja 24, like this I have written. So this is the number of molecules. Okay, I got 8.3 10 raised to 24 molecules. Now, as I said, each molecule equal to 10 electrons. So I have total number of molecules is this much, X equal to 10. Now I can say negative molecules 10, I need to multiply. X is equivalent to total negative charge. Total negative charge. Total negative charge is equivalent to X. You can say which is equivalent to this value, 8.3 10 raised to 24. So there are 10 into 10. Each electronic charge value is 1.6 minus 19. When I do this 8.3 into 1.6, you have already 10, it becomes 25. 25 minus 19, it becomes plus 6. 8.3 into 1.6 gives me close to, I will get 10 raised to plus 6. But 8.3 into 16, something like you do it, you'll get close to 13.3. Or finally, I can say 1.33 10 raised to plus 7. So what is this value? Is equivalent to magnitude 7 coulombs. So I need to write what is the negative charge. It is called coulombs. So cross check 8.3 into 1.6, 8 10 ja 8, something like it becomes 13.3, already plus 25, minus 19 becomes plus 7. If this is a negative charge, yes. If this is a negative charge, then the amount of positive charge will be of the same magnitude because we have same value. So for positive charge, you can say you will have the same value, 1.33 10 raised to 7 coulomb, because you have 10 electrons and 10 protons in case of one molecule of water. So we learned that in this numerical, when you take 250 gram of water, which is equal to 1 cup of water, how much charge is present, how much positive charge, how much negative charge. The positive charge magnitude is 1.33 plus 7 coulombs, and similarly for negative charge also it is 1.33 10 raised to 7 coulombs. Thank you.